This is Numbers with Nicole, and we're going to do a lesson on the equations of perpendicular lines. You can see what you'll be able to do by the end of this lesson based on these bullets right here. So we're going to be discussing equations, and those equations are going to be in slope-intercept form, or y equals mx plus b form. So remember that x and y are a point on the line. They must make the equation of the line true. M is your slope, or the change in y over the change in x. And B is your y-intercept, or the place where the line crosses the y-axis. So that is a 0, comma b coordinate, meaning x equals 0, y equals b. What are the relationships that lines of this slope-intercept form, what can they have? So we're thinking about two different lines here. So they could be the same exact line, meaning their slopes will be equal and their y-intercepts will be equal. So both parts of the line are exactly the same. We've discussed previously parallel lines when we talked about dilations. Parallel lines have equal slopes and their y-intercepts have to be different, because if they are the same, then those two lines are exactly the same. So parallel lines have equal slopes and different y-intercepts. So if you look down here, we have two equations of two lines that are parallel. And notice that the 3/4, the slope portion is the same, but this y-intercept, the +1 and the -3, are different. So the perpendicular lines have slopes that are opposites, meaning that they have different signs. One is positive, one is negative, and they have to be reciprocals, meaning we're going to switch the numerator and the denominator, or the top and the bottom of the number. So if we look down here, we have 3/4 for one of the slopes and -4/3 for the other slope. So the signs are different, meaning they are opposite signs, and the reciprocals, the fractions, have flipped. The y-intercepts should be different unless the point of intersection is the y-intercept. So I'm just going to put different. And you can put a note like unless it's the point of intersection, but I'm not going to ask you about that here. And then for lines that meet none of this criteria, they don't have equal slopes and the slopes are not opposite reciprocals, then they would just be a pair of lines that intersect. So not these relationships. So if we see they're equal or opposite reciprocals, it can't have no relationship. And then again, the y-intercepts could be the same, could be different. It really doesn't matter. Could be equal, could be different. So really what we're looking at is the slope first, and then if we have equal slopes, well, are they the same line or parallel lines? Other than that, we don't really look at y-intercept unless we have equal slopes. Could be equal, could be different. So we'll abbreviate here. All right, so we're going to look at these slopes that are given of two lines, and we're going to determine, are they parallel? I'm going to put the parallel symbol. Are they perpendicular, meaning are the slopes opposite reciprocals, or do they fit neither of these? So I have 12 and -12. The only thing that has changed here is the sign, so this is neither. 8/9 equals 8/9, so this is parallel. 8 and 1/8 does not meet the perpendicular slope because they are not opposite signs. They are reciprocals, but one is not positive and one is not negative, so that is neither. So if you're catching on here and you want to go down and finish some of these examples and then play the video and check your answers, you can do that. So we have 4 and -1/4. Well, remember, any whole number or integer can be written over 1. So 4/1 does become -1/4 when we take the opposite reciprocal, so perpendicular. 9 equals 9, meaning these are parallel slopes. 4/11 and -4/11, neither. We did not see a reciprocal here, even though the signs are opposites. So now I have -4/1 and then -1/4. In order for these to be perpendicular, one of these would have to be positive, so neither. 8/9 equals 8/9. These would be slopes of parallel lines or the same line. And then we have -8/1 and then a positive 1/8. This would be perpendicular. They have opposite signs and are reciprocals. And we have -11/4 and positive 4/11. So again, this would be perpendicular. The signs are different and we have taken the reciprocal. For the last part of the video here, we're going to determine whether the equations demonstrate parallel lines, perpendicular lines, or the same lines. So your first step when you're comparing equations is you want to get them into that y equals mx plus b form so that we can then look at the slope. So let's move this equation around. 2x minus 24 equals 2y. Divide all components by 2. 6x minus 12 equals y. So notice that they have the same slope. And once I look at the slope, which is 6 and 6, since they're equal, I then want to look at the y-intercept. So I have a positive 12 here, and I have a negative 12 here, meaning they are not the same line, they are parallel lines. Let's look at the next one. So both equations in B need to be manipulated. Pretty easy though. So 2/3 x plus 7 for the first one. 3y equals 2x plus 21. Divide all components by 3. Y equals 2/3 x plus 7. I see the slopes are equal, and then I'm going to check the y-intercept, also equal. These are the same line. So remember, we only have to check y-intercepts if we see we have two equal slopes to make sure to see whether they're parallel or the same line. All right, we have our first equation in the correct form. We're going to move our second equation around. 3x minus 7 equals 2y. Divide everything by 2. 3 over 2x minus 7 over 2 equals y. Again, I'm not simplifying that y-intercept right here because I don't need to. I'm only going to really be looking at the slope first. So I have negative 2/3, and if I take the opposite reciprocal, I get 3/2. So these are perpendicular lines. And let's look at our bottom example here. All right, so here I have a slope of 1/5, and let's look at the other line. So that's going to be 2y equals negative x minus 4. Divide everything by 2. Y equals negative 1/2 x minus 2. My slopes are not even close to being the same, so no relationship, meaning these lines will intersect, but that's all we really know.